In this video, I am going to explain circular motion. Circular motion, there are two types: uniform circular motion and non-uniform circular motion. First, let us see uniform circular motion. In uniform circular motion, particle will be moving with constant speed, but the velocity is not constant because the velocity is a vector quantity. So its direction is continuously changing. When it is here, direction of the velocity that side. When it is here, upwards. When it is here, downwards. So but in a uniform circular motion, magnitude of the velocity remains same, but the direction is continuously changing. See the length of this arrow here, same. So magnitude of the velocity is same, but the direction is changing. Here this is the direction of the velocity, here this is the direction of the velocity, but the magnitude is same. Magnitudes are same. Now angle between these two, v1 vector, v2 vector, is theta. Then angle between the radius, here it is a radius vector, r1 vector, this is r2 vector. Always velocity will be perpendicular to the radius vector. See here, this is the radius vector and this is the velocity vector. So it is velocity is always along the tangent. If a particle is to go in a circular path, there is a force is needed which is acting towards the center. That force is what is called a centripetal force. So there is an acceleration. Now let us see centripetal acceleration. I'm going to derive an expression for centripetal acceleration. So velocity, direction of the velocity is continuously changing. Then as per Newton's law, if velocity is to change, force is needed. So if velocity is changing, body is said to have acceleration. Now velocity is changing, even though its magnitude is not changing, its direction is changing. So velocity is changing. So there is an acceleration. That acceleration is called centripetal acceleration. Now this is v1, this is v2. Then this is theta. Then this is also theta, because the velocity vector is always perpendicular to the radius vector. So this is theta, then this is also theta. Then a uniform circular motion, magnitude of r1 vector and magnitude of r2 vector are equal. So it can be written as r. Only the direction is changing. Here it is r1 vector that side, here r2 vector that side, but its magnitudes are same. So magnitude of r1 is same as magnitude of r2 is same as r. Similarly, velocity, magnitude of the velocity are same. So v1 vector, modulus of v1 vector, modulus of v2 vector. You can see the length of this arrow. So it is same. So it is equal to v. Now delta r. Now this is r1, this is r2. So I can represent here r1 vector, r2 vector. Now change in the radius vector. So this is r2 vector, r1 vector. So r2 minus r1 is delta r vector, or r1 vector plus delta r vector is r2 vector. So delta r can be written as r2 vector minus r1 vector. So this is represented here, r1, r2, then delta r. Similarly, v1 vector, v1 vector, then v2 vector, v2 vector. Now v1 vector plus delta v vector is v2 vector. So now delta v can be written as v2 minus v1. Now in this is theta, so this is also theta. So now theta can be written as delta r by r, because r1, modulus of r1 is same as modulus of r2, so it is r. So this theta can be written as delta r by r. Similarly, here also theta, so this theta can be written as delta v by delta V by V. So here only magnitude is enough. This negative sign is because delta V is directed towards the center. Delta V is directed, see this, delta V is directed towards the center. That's why here there is a negative sign. Now after rearranging this, delta V is equal to minus V by R delta R. Rearrange this. So this negative sign can be put this side. Then delta V is equal to minus V by R into delta R. Then for getting the acceleration, divide by delta T. Delta V is the change in the velocity. You divide by delta T. Delta V by delta T. You divide both side by delta T. Here also both side you divide by delta T. So you are getting acceleration. Now delta R by delta T, that is the rate of change of displacement. Delta R by delta T, that is velocity. This is velocity. Again this V, so V square by R. So centripetal acceleration is equal to minus V square by R. Then there is a relation connecting angular velocity and linear velocity. This omega is angular velocity, V is the linear velocity, V is equal to R omega. So for this V we can write R omega, so it's square. R will get cancelled, so A is equal to minus R omega square. So this is the expression for centripetal acceleration. A is equal to minus V square by R. This is a centripetal acceleration. Then centripetal force is mass into acceleration m, then acceleration minus V square by R. So this acceleration is directed towards the center. This acceleration will be directed towards the center. Velocity will be along the tangent, but the centripetal acceleration is directed towards the center. That is why this negative sign. Now let us see non-uniform circular motion. In non-uniform circular motion, speed of the particle is going on changing. Then there will be tangential acceleration. Already we have seen centripetal acceleration. Centripetal acceleration is V square by R. Then tangential acceleration. Velocity is along the tangent. In non-uniform motion, there will be tangential acceleration. Then resultant of these two, centripetal acceleration and tangential acceleration, is acting along this direction. The angle between centripetal acceleration and tangential acceleration is 90 degrees. Then we have to get the resultant of these two. Resultant of two vector is given by this relation. Magnitude of the resultant is equal to square root of p square plus q square plus 2pq cos theta. In this case, theta is 90 degree. Here two vectors, AC and AT. Then angle between the two vectors is 90, cos 90 is 0. So resultant is square root of p square plus q square. So here resultant acceleration is square root of AT square plus AC square. Now resultant acceleration is equal to square root of AT square plus AC. This is centripetal acceleration. Centripetal acceleration is V square by R, its square. So we can get the resultant acceleration. Now resultant acceleration is acting along this direction. So that is making an angle theta with the centripetal acceleration. So it can be resolved into two components. Along the radius, centripetal acceleration, that is AR into cos theta. Then perpendicular to that, AR sin theta, tangential acceleration. When you divide this equation by this equation, AR will get cancelled. Sin theta by cos theta is tan theta. Tan theta is AT by AC, tangential acceleration divided by centripetal acceleration. Centripetal acceleration is V square by R. So we can get the angle. Thank you for watching.